Okay, so here we go, rectangles, guys. Happy Monday. Is it Martin Luther King Day? I think so. Eileen. Yes, Eileen, the one from Friday. Okay, so here come, we're going to recognize and apply properties of rectangles. We're going to determine whether parallelograms are rectangles. So here are some important ideas. You need to know these real quick. Properties of rectangles. A rectangle is a parallelogram with 4 right angles. You see this? By definition, a rectangle has the following properties. All 4 angles are right angles. Opposite sides of a parallelogram are congruent. Opposite angles are congruent. Consecutive angles, like A and B and A and D, are supplementary. Diagonals bisect each other. Can you all think of a special rectangle? Can you all think of a special rectangle? Anybody? Anybody? What about a square? Pretty cool, right? So in this situation, a square now has opposite sides congruent, right? Parallel congruent. But in this situation, for it to be a square, then all of them are congruent. That's the only difference. Pretty cool, right? So a rectangle and a square are kind of the same thing. A square is just a special rectangle. So do me a favor, guys. Copy this down real quick. Make sure you know this. All 4 angles are right angles. Just go ahead and abbreviate that really short, really quick. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. Okay, if a parallelogram is a rectangle, then its diagonals are congruent. So this is the only new thing about parallelograms. Remember, parallelograms usually had one longer, one shorter, because it was kind of like a slanted one of these, slash pushing. Maybe it was these two closer together and these further. But in this situation, they are equal, and they go ahead and, well, still bisect each other. So if a parallelogram is a rectangle, diagonals are congruent. If a parallelogram JKLM is a rectangle, then line segment JL is congruent to line segment MK. That's it, pretty easy. Okay, copy that one down about 1 minute real quick. Okay, so we're going to use the properties of a rectangle. We'll do some of these questions. The Texas Park and Wildlife Organization plans to add 2 diagonal walking paths as shown. So here's this rectangle, I guess, park, and they're going to add 2 diagonal walking paths to one of its rectangular parks. If PS, where's PS? From here to here is 180 meters, and PR is 200 meters. PR 200 meters. Find QT. Okay, so in this situation, they gave us this side length of the rectangle. They gave us this diagonal, and now they want us to find this part here. Well, the cool thing about this one, you can approach it any way you want. As far as me, since I know diagonals are congruent, I know this one's what? 200? So I'm going to say this one's also 200. Since they bisect each other, this one going at 200, this one should be at 200. When they cross right here in the middle, they bisect each other, so this should be 100. And so their QT is equal to 100. It's not too bad, it's pretty easy. Going once, going twice. You have any questions on that one? Okay, so let's go and try this one real quick. So draw like the cheapy kind of triangle right there. You don't have to put the trees and the benches. PQ, RS, T, and let's go ahead and find the answers. If TS is 120, TS is 120. Well, that's 120. We already know that's 240. That's 240. That's 120, 120. Find PR. Oh, that's pretty easy, right? So question 1A. If TS is 120, so from here to here is 120. Well, just make sure you know, all of this is also 120, right? They bisect each other. This diagonal is 240. From here to here is 240. So we can go and say, I go SQ is also known as, well, the book would go with ST plus TQ. So we're going to come out here and say ST, TQ, right? This ST was given to us at 120 plus another 120. They're going to go ahead and say SQ, the whole diagonal, is equal to 240. They're asking us for PR. And since it is a rectangle, since this one is a rectangle, we know that what? PR is congruent to SQ. So we're going to say what? PR is congruent to 240, or equal to 240. Pretty easy, pretty cheesy. Go ahead and try 1B real quick. Okay, I'm going to erase these numbers for 1A. Before I move on, do you have any questions about 1A? Let's try 1B. It's a measurement of angle PRS. PRS. I'm talking about this angle here. Is 64. Find the measure of angle SQ. SQ. Does anybody know how to do this one? Yeah, but what do we know so far? Anybody? Come on, let's think. Let's think. Is it too early on Monday? Okay, so make sure you know all angles are 90 degrees, right? It's a rectangle. And then you also know that when you have this plus this, they're 180 also. So let's see what we can do here. Anybody know what to do here? Yeah, I'm going to go with that. Okay, since this part here I know it's 90. I'm going to go with 90 minus 64. That gives me, you're okay with that one? What do y'all think so far? Everybody okay with that one? Can anybody think of anything here? Anything here? So I know this one right here is 26. Going once, going twice. Anybody have any ideas here? I'm going to look at it like this if you don't mind. What do I know about this shape that's created here? Isn't it a triangle? And what do I know about this line and this line here? They're congruent. So doesn't it become like an isosceles triangle, kind of? So without doing much more math, I'm just going to do it. Hey, you know what? I could approach it by supplementary, do some other stuff here. I'm going to say, you know what? Since this diagonal and this diagonal are equal to each other, they bisect each other. So I'm going to get this equal to this one. That becomes an isosceles triangle. And these two would be my base angles. So what do you think this one would be here, right here? Right here in the same kind of position here, opposite the congruent sides. 26. So we're going to go with angle. Yes, thank you, Eileen. We're going to go with angle. What angle is it looking for? The measurement of angle SQR. Make sure I'm doing it right. SQR. Yeah. The measurement of SQR is equal to 26. And I just kind of made it an obvious, or kind of like, thank God we have this geometry. We can prove that it's a isosceles triangle. Diagonals equal, bisect each other, giving me two equal halves. You think about that. That forms a triangle. And we know the opposite, or the base angles of a triangle have to be the same. We figure this one to be 26. That one's 26. Check. Okay, let's come on here. Quadrilateral JKLM is a rectangle. Okay, so make sure you know 90, 90, 90, 90 equal to each other, bisect each other, congruent, congruent, congruent to each other, cross, supplementary, stuff like that. Let's go for it here. And quadrilateral JKLM is a rectangle. If measurement of angle K, okay, so we have this quadrilateral JKM, it's a rectangle, JKLM. They're giving us that measurement of KJL, angle KJL is that, and the measurement of angle JLK is that. They wanted to find out X. Do y'all see anything, guys? Anybody see anything to do here? Angle? Okay, so for this one, I'm going to see a triangle here if y'all see it. Y'all see it right there? Okay, this one's already 90 degrees because it is a rectangle. So these two have to do what? Okay, so all three angles of a triangle add up to 180. This one's already 90. So these two have to add up to give me 90. So what I'm going to say here, you know what? Exactly what the book did here. And actually, that's the way I was thinking about it. If I get this angle here plus this angle here, it has to be the remaining 90 degrees, right? Set them up like that. Solve for X, and X is equal to 9. Not too bad. So remember, these are rectangles, but anything we've learned before, parallelograms, / rectangles, triangles, whatever, surface area, volume, you can apply it. May move it up. Okay, there we go. Okay, refer to this figure right here. Let's look at this part real quick. They're giving us JP to be equal to 3y minus 5, and they're giving us MK to be equal to 5y plus 1. Find y. So give you a couple of, like a minute to copy it down, and we'll do the work right here. Okay, so here's the figure that we want to refer to, and then these are measurements, JP, MK, and we'll go from there. I gave about. Okay, let's look at this one real quick. Refer to the figure. So we have JP going half of the diagonal. So from here to here, that is going to be, I'll put it right here, 3y minus 5. MK, the whole distance from here to here is going to be 5y plus 1. They want us to figure out what y is regarding these things. What relationship do these guys have? Do y'all know what they have? See, we're comparing this length right here, right? You can say this is half of that. I personally don't like that because of the half. Ooh, not cool. I would say 2 of these is equal to that one, right? Since the diagonals are, basically the same of a rectangle, they're congruent. They bisect each other. They give us half here of one diagonal slash, I know this one is now half of this one. I don't like that. I'm going to say this one over here is 2 of those. I'm just going to set that up. So I'm going to get 2, 3y minus 5, okay, times 2 is equal to 5y plus 1. And work it up from there. 6y minus 10 is equal to 5y plus 1 minus 5y. Cancels here. We're going to go with y minus 10 is equal to 1. We're going to add 10. We're going to go with y is equal to 11. And there it is. What do y'all think? Not too bad? Pretty easy? Yeah. Okay, we got it. 11. We're good. Everything all right? Okay, last thing we're going to cover for today, today's lesson is almost over, is this right here. Okay, the converse. So if we can prove, okay, if we can prove that the diagonals of a parallelogram, are congruent, then what do we know? So the diagonals of a parallelogram are congruent. We got some parallelogram out there, and we figured out that the diagonals are congruent, then the parallelogram is a rectangle. So copy that down real quick. So if we see out there we have some kind of parallelogram, whatever it is. They gave us the measurements, it looks pretty good, but they didn't tell us it was a rectangle. And we figure out that the diagonals are congruent to each other. Then we now know it's a rectangle. Yeah. This, what we're going to prove here, what we're going to want to, it says right here actually, wy, this part right here is congruent to this part here. If we can prove that, then it is a rectangle. And the cool thing, if it's a rectangle, guys, they're all 90 degrees. Opposite sides are parallel and congruent. Diagonals bisect each other. A lot of cool things happen here. Okay, so let's look at this real quick. A community recreation center has created an outdoor dodgeball playing field. That'd be super cool. Don't worry, I would totally annihilate you all. I would hit you in the face on accident. Just saying, if there was a dodgeball area. To be sure that it meets an ideal playing field requirements, they measure the sides of the field and its diagonals. Okay, so AB is 60 feet. Let me just, while I'm talking here, I'll just put the numbers up. So they measure this to be 60 feet. They measured BC to be 30 feet. CD, 60 feet. AD, 30 feet. Then they figured out AC, from A to C, 67 feet. And then BD, 67 feet. All right. Explain how the recreation center can be sure that the playing field is a rectangle. Which of these things makes it rectangle? Yeah. What makes it a rectangle, guys? So yes, I see this and I see that. All right. We could have it like this: 60 feet and hear me, 60 feet here. Do you agree? We could have it 30 feet here and 30 feet here. That's still 60, right? And 60, 30, and 30. What is this? It's a parallelogram. This right here is also a parallelogram. Why is this one a rectangle and this one not? Yeah, because the diagonals are equal. If you look at this diagonal here, it's obviously shorter than this diagonal here. And a rectangle, they're equal to each other. So basically, all I got to come out here and say, hey, you know what? It satisfies the parallelogram conditions. The opposite sides are congruent, yada, yada, yada. But since the diagonals, AC and BD, are congruent, now it makes it a rectangle. Is that pretty cool or what? I think it's a pretty cool idea. It's pretty powerful. But we're not going to do this one. I think this one's kind of, I explained this one already. But they want to say, is this a rectangle? Is this a rectangle, guys? What do y'all think? How do we prove for us now that it's a rectangle? Okay, we know 90 degrees, 90 degrees now. Anybody can prove that this is a rectangle? Anybody know how to prove this is a rectangle? Yeah, we look at the diagonals. Diagonals. Now, from here to here, if you don't mind, I'm just going to look at this real quick. What do you automatically see there, if you don't mind? I'm going to see a squared plus b squared equals c squared. And this is my c right there. When I have this part right here, if you don't mind, I'm going to go 36 squared plus 80 squared equals c squared. I'm not going to solve it. If you don't mind, I'm not going to solve it. If I do this diagonal here, well, what's this diagonal? Isn't it again a squared plus b squared equals c squared? And here, I already told you, it doesn't matter where you put the, I guess, the a and the b. It doesn't matter. So I'm going to set it up the same way. Wait, if I set it up the same way, wouldn't I get the same answer? So my c's here are equal to each other. So slash, I prove that my diagonals are congruent slash my c's. So it is a it is a rectangle. Pretty cool. What do y'all think? Do y'all want to do the work and prove it? Are you good? Come on, guys. It's Monday. Y'all are killing me. Okay, we're going to stop there. Go do Alex for the rest of the time. We got about 20 minutes, 22 minutes to be exact-ish. So for 22 minutes, get busy doing Alex. After the 22 minutes, we'll see you tomorrow. But you also have, I'm giving you time right now to go